Yeah, good day, everyone. This is Mr. Wale, and I'm taking you physics. As you can see on the screen, our topic today is simple harmonic motion. Simple harmonic motion. Now, before I go fully into the topics, I believe when you were in SS1, you were taught motion and you were given the types of motion. And we learned that among the types of motion, we have what you call the oscillatory motion. And we look at one of the examples of an oscillatory motion. We discover that one of the example of a body performing explosion is what? When the body is what? Performing simple harmonic motion. So now we are going fully into what is called motion. What is simple harmonic motion? Simple harmonic motion simply means the to and fro movement of an object about a fixed point whose acceleration is directly proportional to its displacement from a fixed point, and it is always directed towards that point. What do you mean here? Well, it's like a simple body performing simple harmonic. Simple, an example is a simple pendulum. You discover when you tight a wire on a bulb and you attach it to a wall. By the time you, at that moment, the wire and the bulb are at equilibrium position. But if there is just a slight displacement, you discover that the body will be moving, go up, then let it come back. So the process of moving back and forth is what is referred to as the to and fro movement of the object, or it is vibrating. Simply say vibration of a vibrating object. You can put it that way. It will always move towards that fixed position. And we say that what the acceleration is directly proportional to what? To the displacement from that fixed position. Some examples of simple harmonic motion are: one, singing of a pendulum bump, and we have two, heartbeats. Number three is movement of piston in an automobile engine. Four, plug strings such as guitar. Five, movement of mass hanging from a spiral spring. Six, springs of a tuning fork. Seven, a loading test tube floating and oscillating vertically in a liquid. So those are examples of what? Of simple harmonic motion. Now, before we can continue, let us learn some basic terms that are used when we are explaining simple harmonic motion. What are these terms? The first one is cycle. First one is cycle. A cycle is one complete revolution of an object about a reference point. What do we mean by that? When a body moves round a circle, we say that what? It has complete one cycle. One cycle. And it has make what? One revolution. It has make one revolution. And one revolution is equal to 360 degree centigrade. And sorry, 360 degree. Number two is period. The period of a simple harmonic motion is simply the time taken by the objects to make one complete cycle. That is, to complete one revolution. The time to complete one revolution is referred to as the what? As the period. It's referred to as the period. So an expression for that is what? It is represented by a capital letter T, and the formula for it is what? T is what? Time over N. Where that small t there is what? Is the time taking, and N is the number of oscillations. Where that capital T is the period of oscillation. So if you are to obtain our period of oscillation, so we have T equal to small t over small n. So In the laboratory, we can easily practicalize this by using a simple pendulum. And we have that the unit of the period is seconds. The unit of period is seconds. Seconds. Number three things we need to know is the amplitude. The amplitude of a simple harmonic motion simply means the maximum displacement that the body would attain during oscillation. The maximum displacement a body attain during oscillation. And it is always measured from what? From the equilibrium position. It is always measured from the equilibrium position. The unit there is meter. Why number four, we have the frequency. The frequency, this is the number of circles made by the body in one seconds. That's the number of oscillation that the body makes in just 1 second is what we refer to as what? As frequency. The number of circles in which what the body made in 1 second. That is number of to and fro that can cover in 1 second is what we mean by what? By frequency. And the unit is what? Is per seconds. The unit is per seconds, which is what? Which is can also be written as what? As hertz. As hertz. And the frequency is given as the what? The reciprocal of period. That is, F is simply equal to 1 over T. So 1 over T. We know that our T is what? Is small t over n. So if you are to look for F here, it will be what? It will be small n over T. We just have to look for the reciprocal of what? Of T, which is what? 1 over T. And the period is also expressed as what? As 2 pi over omega. It is expressed as 2 pi over omega, where omega is simply what? It's a Greek word which symbolizes what? The angular velocity. Which symbolize the angular velocity. Another formula that you can use for period is what? That T equal to 2 pi square root into L over G. 2 pi square root into L over G. Very good. Now, what we are going to discuss here now, after we have learned about the time we need to use, we are going to learn about the common terms. That is what? The displacement of a simple harmonic motion. We discuss on the velocity, the acceleration, and energy that is possessed by a simple harmonic motion. To start with, we are going to start with the displacement of a body that is performing simple harmonic motion. A body's the displacement is always given can be obtained by a sinusoidal graph, by what we call what? A sinusoidal graph. And the displacement from the sinusoidal graph is given as what? A sine theta. A sine theta. As we all know, as we have known from the beginning, that our A means what? Amplitude. Y theta is the angle that what? The cycle make with what? With the plane. And from our idea of circular motion, we know that what? Our theta is always equal to omega t, where they are from where we have omega equal to what? Theta over t. So if you make theta subject to a formula, they are very sorry. What I've just explained there is not on this note. So maybe consequently, we are going to add it to it. So the displacement can either be in the vertical component or in the what? In the horizontal component. So for the vertical component, we have y equal to a sine omega t, and for horizontal component, we have x equal to a cos omega t. Now, velocity of a body undergoing simple harmonic motion. Now, like what I've explained the other time, I said, look at this diagram. I said, if we perform a simple pendulum, look at the points from the horizontal plane there, then look at those dotted lines to 0. That is the equilibrium position. That is what? The equilibrium position. Now, if you not displace it, you discover that what? The body will move from that equilibrium position 0 to B, Then after moving, it will not move from B, then pass through that 0, that equilibrium position, then move back to what? To A. So those are the things that happen or occur during simple harmonic motion. To and fro, it move from 0 to B, B to 0, 0 to A, and A back to what? To 0. So then we say that what? It has complete one oscillation. Now, if you look at that very well, the displacement at B is maximum. The displacement at B is maximum. That's the distance it's covered. When you get to B here, it will not come back. So we say that the maximum, it has what? Maximum speed. While what? The velocity at the point of equilibrium is what? Is maximum. Is maximum. Please pardon me with this. This is supposed to be MAX, not MN. MAN. So it's supposed to be maximum. So as we can see from the diagram, since we know the movement, how it oscillates, then we now look at the condition for the velocity now. When the velocity is at maximum, that is possible what? At equilibrium position. Then we have that V equal to maximum. And the formula we use there is what? V equal to omega R. I've told you what omega is the other time. And if, let's assume that the point is not at maximum, then the velocity is, let's say, assume that it's between O to A at a certain instance. Then the formula we use is V equal to omega into square root into R square minus Y square. Note this. R means what? Maximum position. And what is our maximum position? It means amplitude. So if you are not saying it to be A simply means what? Is the same thing as R, which is what? Maximum displacement. Then when Y is equal to R, at maximum displacement, V is always equal to 0. So at point B and A there, V will be equal to what? 0. Now, let us consider the acceleration. Acceleration of a body performing harmonic motion is given as, from our definition, we said that it will be directly proportional. This displacement is what? Directly proportional to the acceleration. So the acceleration here is equal to A equal to minus omega square R. Or I can write to what? To be minus omega square A. That is what? When it is at maximum. When the acceleration is at a certain instance, it will not be maximum now. So you can say that value is at Y or S. Instead of me using R or A, so I make it to be X or Y. And when it is at equilibrium position, A is always equal to 0. That is when it is at A or B. A is also equal to, when it is at what? O, then A is equal to 0. Now, let us look at the energy of a simple harmonic. Energy possessed by a simple harmonic motion are always conserved. They are always conserved. You have the knowledge from your conservation of energy that what? When a body is conserved, it means that the potential energy will be equal to what? Kinetic energy. There will be no loss in energy. Energy at the potential level will be equal to energy at the kinetic energy level. So we have it to be mgh equal to half mv squared. Thus, we can have from our elastic force, we have that half equal to what? Kf squared, or we say that what? Energy equal to half Ke squared. Period T of a simple pendulum is given as, these are just the summary of the formula we need to use under simple harmonic motion. Period T is equal to 2 pi square root into L over G. While the period for a loaded spiral spring, T equal to 2 pi square root M over K, where M is the mass and K is the what? Is the force constant. While in a test tube, we have it to be 2 equal to 2 pi M over rho. 2 pi M over 2 pi M over P, where our pressure, that is the the pressure of the liquid, where the pressure is given as what? Rho g h, where rho is the density and g is the acceleration due to gravity, and g there, h there is the height of the liquid. So those are the three formula that we may need to know when solving problems on simple harmonic motion. Now let us look at an example. They said a body of mass 20 grams is suspended from the end of a spiral spring whose force constant is 0.4 Newton per meter. Full stop. The body is set into simple harmonic motion with amplitude of 40 centimeter. Full stop. Calculate A, period of oscillation, B, frequency of the motion, C, angular speed, D, total energy, E, maximum velocity of the motion, F, maximum acceleration. Now, solution. The first thing we do here before we start calculating is what? We draw out our parameters. What are the parameters given us in the question? We are given that what? The mass of the body is 20 grams, and we are given the force constant to be what? 0.4 Newton per meter. And also we are given the maximum displacement, which is known as what? The amplitude, to be what? 40 centimeter. Now, since the force constant is in basic unit, what we need to do is what? We need to convert every of our value to what? To basic unit, which means that 20 grams will be converted to what? To basic unit, which is kilogram, and the amplitude will also be converted to what? To meter. So that is what you have on the board here. The first question says we should find the frequency. And what is the frequency from the note given to us? We said that period F is simply equal to what? 1 over F. 1 over F. But from the question given to us, we are not giving F. What do we need to do before we obtain our P? We are giving M, we are giving K, and we are giving A. Now, this is what we do. We know that our F is equal to what? Omega over 2 pi. And if you make omega subject of formula, it gives us what? F 2 pi F. It will give us 2 pi F. And we know that what? Our omega is equal to square root of K over M. So from there, we know our K, we know our M from the given values given to us. So we just need to substitute, so that we have it to be omega equal to square root of 0.4 divided by 0.02. And when you solve it, you have that your omega will be equal to what? 4.47 rad per second. Sorry for the missing unit there. 4.47 rad per seconds. As I've said the other time, I say omega is equal to 2 pi F. So if I make my F subject of formula, I have omega equal to 2 over, and F equal to omega over 2 pi. Where my F already I've gotten that to be what? I've gotten my W to be 4.47, and that is 2 times pi is a constant, 20 over 7 or 3.142. When you do your calculation very well, you are going to obtain 0.71 hertz. Now, since we have obtained F, which means we can easily obtain our T, which is what? 1 over F. So if we put it to be 1 over 0.71 now, then our period will be given as what? 1.4 seconds. Really, from what we have done now, we have solved almost 3 questions. We have solved almost 3 questions from the question given to us. We have been able to obtain the frequency, the angular speed, which is also known the angular velocity, and the period. Now, we have solved 3 questions there. Then now it is left for us to solve the D question, which is what? Total energy. Total energy. From law of conservation of energy, total energy is simply equal to potential energy plus what? Kinetic energy. Our kinetic energy is half mv squared, while potential energy is half ks squared. Now, so since the potential energy is at maximum in this case, then it means that V equal to 0. Definitely Our total energy here equal to what? 1 over 2ks squared. So if you substitute all our value, the force constant and the displacement 0.4, then we discover that we are going to find the total energy to be 0.032 joules. Now the velocity now. Velocity is equal to omega A. We all know that. It's equal to omega A. We all know that. So that is what 4.47 squared there, 10 times 0.4. When you do your calculation very well, you discover that you have 7.99 meter per seconds. 99 meter per seconds. So if you are to solve for the acceleration now, acceleration is what? Minus omega square s. Omega square s. So if you do your substitution very well, then you have the answer that we have there, which is 7.99. Now, what I have for you now is just a practice question. As you can have it on the screen there, please try it. And if you have anything, comment, just drop your comments, or any explanation concerning the question, drop your comment, then I will respond as usual. Thank you very much.